Right, everybody should have drawn a right triangle, labeled it A, B, and C. If you haven't done that, what's going to happen, guys, if you have this written on your paper and a blank, that's what's going to be on your test. I told you what to do, even. On the test, I'm not going to tell you what to do. It's just going to say this. Prove this. You have to draw a right triangle to prove this. Any right triangle will work, but ABC is the one I'm going to draw. So draw your right triangle, ABC. What's this angle?
Right,
C. Always label your right angle C, because if you use the Pythagorean theorem or standard, we usually use C for our largest angle. Doesn't matter which one you put on A and B, but I'm going to put it this way. I like to have A as my smallest one. Angle A is across from side A, which is the smallest side. Angle C is across from the hypotenuse, which is the longest side. Angle B is across from the middle side, which is B. There's a labeled triangle. Now I want you to write the sine, cosine, and tangent of A and the sine, cosine, and tangent of B. Go ahead. Do more than just write the question. You actually have to write the answer as well. Write the sine, cosine, and tangent of B as well. Sine of A?
A over C.
A over C. Cosine of A?
B over C.
And the tangent of A?
A over B.
A over B. Always.
Excuse me.
Yes?
Is Judith Elizalde in class today?
Who?
Judith Elizalde?
Judy? Yes.
Can you send her to the library? She needs to take the AccuPlacer.
Okay.
Thank you.
Sine B?
B over C.
B over C. Cosine of B?
A over C.
A over C. I want you to notice something really important. It's going to be one of your big trig identities today. Does everybody see that the cosine of A is equal to the sine of B? That's because you switch the opposite and the adjacent sides when you change from one angle to the other. Something else I want you to keep in mind is that A and B are complements of one another. The sum of A and B is? That's true too. What do you get when you add A and B together? What angle? 90 degrees, or, how do we say it in radians? Pi over 2. So A and B are complements, and one way to write them is to say that A is, say, x degrees, and this angle is 90 minus x degrees, isn't it? Because when they add them together, you get 90. So I can say this is 90 minus x in degrees, or I can say pi over 2 minus x if I'm talking about radians. It doesn't matter which type of angle you use. They're called complementary angles. And I want you to notice, the sine of A is equal to the cosine of B. And the cosine of A is equal to the sine of B. And the tangent of A and the tangent of B are related. Isn't the tangent of B B over A? These are called reciprocals of each other, and we call the reciprocal of tangent cotangent. So we say that these are reciprocals. They're not equal to one another, but they are reciprocals. If I say the tangent of A, it's equal to the cotangent of B, and vice versa. That's a lot of stuff. But this is what we want to prove. All we need to do is take the sine of A and divide it by the cosine of A. Try it. Take the sine of A. Well, I'm just going to put a little arrow. Sine of A divided by the cosine of A. This is the same thing as saying the sine of A divided by the cosine of A. When we talk about fractions, it's usually easier to do this, isn't it? What was the sine of A?
A over C.
A over C. The cosine of A?
B over C.
B over C. Now, when you divide fractions, you're not supposed to divide them. You're certainly not supposed to cross-multiply them. You're supposed to multiply by the reciprocal. We change the operation to its opposite, which is multiplication, and we multiply by the reciprocal, which is
C over B.
C over B. So we have A over C multiplied by C over B. No, you never change the first one. You're not dividing by this, you're dividing by this. You understand the difference? Okay. Just like when you subtract, you change the sign of the second one. Got it? Okay. So now, what do we got? C divided by C is 1. What's that?
A over B.
A over B. Well, I think I recognize that. What is that called? The tangent of A. The sine of A divided by the cosine of A gives you the tangent of A. Tangent is sine over cosine, always. There's never an exception. You can do the same thing with B, right? Can everybody see I'm going to have B over C divided by A over C? And I'm going to get B over A, which is the tangent of B. It's going to work every single time. That's what's special about trig identities. For any type of angle that I choose, I can put any number in here, and it's going to be true. Pretty clear on that? That's a big idea. That's your first trig identity.